in order to figure out the path that it's following, I want to know the velocity in the x direction and the velocity in the y direction. Right? The velocity in the x direction and velocity in the y direction is going to give us the velocity after it goes through the plates. So I want to know Vy and Vx. I guess I didn't need to know delta y, but it doesn't matter. So therefore, Vy is Ayt because V0y is 0. Okay, I'm going to write this on the next page. Vy equals A sub yt, and Vx equals delta x over t. So therefore, Vy over Vx is equal to Ayt squared over delta x. What we want to get rid of here is time. So we can actually use, since we do know v sub x and delta x, we can actually use time, which we had solved for on the other page, delta x over v sub x, delta x over v sub x, and go ahead and plug that back into here. So therefore, Vy over Vx is equal to, using the kinematics, we get that. And you might say, oh wait, why am I solving Vy over Vx? I'm solving for Vy over Vx because of the triangle that we just drew, right? This triangle, you can see that the theta that we're interested in, theta, tan theta is Vy over Vx. So this is equal to tan theta. So therefore, tangent of theta is equal to Ay delta x over v sub x quantity squared over delta x. Tan theta equals QE delta x over mvx squared. Okay, so is this the final answer? What does this tell us? All right, this tells us the deflection angle is dependent on the charge of these cathode rays divided by the mass of these cathode rays times the electric field which we set, delta x which we set, and v sub x which we measure ahead of time. Remember, it was measured by the velocity selector. So these three quantities that I've circled are known, and the only unknown quantity is this quantity q over m, charge over mass. And you say, well, now, so again, remember, so what's circled, the E, delta x, and V sub x, are fixed quantities. Whether they're known or not, they're fixed quantities. We fix them in this apparatus. And then we look at the deflection angle of the cathode rays. And what we learn is that when J.J. Thompson does this experiment, remember J.J. Thompson did this experiment in the 1890s, Thompson, 1897, and what he found was that theta is a constant. In other words, that it didn't matter what he used as a cathode material. Filament, when you boil off these cathode rays that you accelerate in this apparatus, he found that theta was always the same. For a fixed electric field, a fixed velocity, and a fixed delta x, that theta is always the same no matter what the cathode rays came from. What does that tell you? What that tells you is that Q over M is a constant. So what J.J. Thompson was able to figure out is that because the angle of deflection didn't change no matter what he used as cathode rays, that it told you that they're made up of the same thing. They're all made up of the same thing because Q over M is a constant. Because theta is a constant, Q over M is a constant. They're all made up of the same thing. And he decided that those were these small particles you can't see and he named them electrons. Okay, so this is the conclusion I just tried to talk about. We have now discovered something that has a charge to mass ratio of Q over M. And JJ was able to go ahead and measure that charge to mass ratio. And that charge to mass ratio was nothing like anything that had been measured before and was much smaller than anything measured before, or bigger depending on, I don't know. It was very different than anything measured before. Therefore, it's a new particle, which is the electron. Okay, so we've discovered a new particle. Let me just look a little closer at this equation. Tan theta, just to make sure that we understand that Q over M are the unknowns and the rest of what we set. We know that delta X is the length of the capacitor plates, And we know that E is the electric field between the capacitor plates. But we don't actually set E. What we set is delta V. And so where the capacitor plates have a separation of D. And so recall that what we're actually setting here is a voltage. And that voltage is defined as the integral of the electric field dotted with dr. So for the capacitor plates where the electric field is a constant, remember that electric field is a constant between two parallel plates. So for E equals a constant, therefore, and R, the distance as we go from one plate to the other, is along E. So E dot dr is the integral of E dr times the cosine of the angle between E and dr. If dr is in that direction, then it's just delta V equals the integral of E dr. E is a constant, so delta V equals E integral of dr. So it's just delta V equals E times dr. The distance from one plate to the other is D. What I did do is I left out a negative sign. Hopefully somebody caught that. In this definition, delta V is minus E dot dr, so there's a minus sign everywhere. That minus sign actually doesn't matter for this derivation, which is why I inadvertently left it out, because all we care about here are magnitudes. And the direction of deflection is going to be, this minus sign will tell you about the direction of the deflection of the electron, but in terms of the angle of deflection that we're talking about, angle of deflection, whether it's up or down, it's theta. It doesn't matter whether it's minus ED or plus ED. But this is correctly minus E times D. So the magnitude is E times D. And then remember also from the selector, the velocity selector, we found that the velocity, v sub x, is equal to E over B. So therefore, we get that tan theta is equal to, so tan theta, we can just replace v sub x with E over B, and then we can replace E with delta V over D. So in the end, this is just rewriting it in terms of things that we can actually set. We can, delta x is, now looking at this equation, Q over M is this unknown. Delta x is the length of the plate, B is the magnetic field that we set with the Helmholtz coil, D is the distance between the two capacitor plates, and delta V is the potential that we set across the plate. So Q over M is the only unknown, and that's what JJ is using this equation, measuring theta, in order to determine Q over M after he sets all of these quantities. Ta-da!